So hello everybody to this today's web talk and our web talk series on AI for societal goods, or for SDGs as we named it. My name is Katja Lasch. I'm the director of the German Center for Research Innovation and also for the German Academic Exchange Service in India, better known as DAAD. We are today on our second day of a inspiring web talk series dealing with AI for SDGs, and the focus topic of today is AI in health. Yesterday we dealt with AI in agriculture. We learned a lot. We learned a lot of things about India, about Germany, but also what we have in common, where we could connect, where the problems are. And one of my main takeaways was yesterday that's all about data and about how we deal with data. And I'm really looking forward to see how the discussion is today ongoing in the field of health. AI is one of the key technologies shaping the future, which is already altering the world. And it's creating better solutions for societal goods, but there are also, of course, a lot of ethical questions behind, also a lot of questions if it would advance for fulfillment of the SDG, or if it would even put some barriers into that. AI is addressed as well as in the AI strategy of India and Germany, which were both published in 2018. And we see a lot of investment in AI in health in both of the countries. So currently, Germany has decided to fund 3 international centers for AI. One of them is dealing with health, and we are extremely proud that we have one speaker of the center today with us. But it's not just the case in Germany, also in India. We've seen a couple of new AI centers upcoming. One dealing with health is the AI center in Hyderabad, which is a co-funding between the government and the industry, and I'm also glad that we managed to get somebody on board here. The German Center for Research and Innovation is a network of 18 German research organizations, universities, and funding bodies who are present in India, and we are funded by the Federal Foreign Office of Germany, and it's managed by the DAAD. Our scope is to promote research, to promote the German research landscape, but more important is to enhance the research cooperation between India and Germany. And here we are arranging networking meetings, information sharing, and of course, this session is one of these events. So for us, it's always important in our events, in our activities, to showcase the German landscape to India, but also the Indian landscape to Germany. We are covering all fields of research from basic to applied research. And in this year, we have focusing a lot on citizen climate and on artificial intelligence. Bit of housekeeping for today's meeting. So this is an interactive meeting. That's why we are not streaming. That's why we are live in WebEx. So to the audience, and I see we already have more than 50 attendants in the audience. Feel free to put your questions in the chat. We will take them up in the discussion. I will take care that we answer most of the questions, hopefully, in the Q&A session. Additional information on the AI landscape in India and Germany, and also on the projects institution to be presented in this web talk can be found either on our website, and our colleagues will be also take care in the chat to post some useful links so that you could have a bit of a further reading later on. In our web talk series, we have one more event upcoming tomorrow. Today we are dealing with health. Tomorrow education is the focus. Tomorrow we will discuss software developments and applications for school and higher education, covering topics such as mentoring, student assessment, and students' learning journey. But that's for tomorrow. Registration is still possible. Last but not least, I want to thank our partners for the web talk series. For this series, we partnered up with India AI, the AI portal of India, and the Bavarian Indian Center, and especially for today, we partnered up with the German Center for Research and Innovation in Tokyo, and we are glad to broaden our Indo-German perspectives a bit and have Professor Miano on board connected from Tokyo. I'm looking forward to an interesting and engaging discussion. I hand over to Almut Wietholz, who is connected from Berlin. She is working within the Leibniz Gemeinschaft Association and is responsible for international relations. China and India are are the key or the focus country of her work. So really glad to have you on board, Almut. Hand over to you, and the floor is yours. And of course, the floor is also open for our speakers.
Hey, thank you, Katja, and also thank you, Adishri and Ramneet and Garima, of the whole team of the DWIH, the German Center for Research and Innovation, for organizing this series. I thought it was very exciting to watch yesterday's bit. And well, today we're off to AI and health and healthcare. So let me start by saying that I have this inkling that most of us have learned quite a bit about biology and virology and healthcare in the past year and a half, and understood most or more about the terrible complexity of healthcare and all its facets, which obviously do not just include medical sciences, but also individual and social psychology and public health questions and political decision making and everything related to it, from negotiations about data protection and the working of smartphone apps or not working in our case, and individual and societal behavior and responsibility. So let me just say that I'm very honored and excited to be allowed to moderate today's talk. And I'd like to welcome not just the listeners and watchers and viewers to this talk, but especially the 4 speakers for spending their very, very precious time here with us. So thank you in advance for sharing your work with us, and also thank you for allowing us to pick your brains afterwards. So the way we'll do this is that I would like to ask the speakers to give short presentations about their work, one after another. And then once we've heard from all of them, I'm sure there will be loads of questions from the audience. And I have a couple of questions myself. And I thought it would be nice if we started with the fundamentals. That is, I'd like to ask Professors Satoru Miyano and Wolfgang Neidl to start. And then we'll move on to the practical applications and the implementation and translation and even commercialization with Professor Priya Kumar and Dr. Höfner. So in this sense, Professor Miyano, the floor is yours. I'd like to ask you to start with your presentations. Thank you.
Sure. Thank you. Thank you for introduction. File will be shared. Wonderful. My name is Satoru Miyano. I was director of the Human Genome Center, University of Tokyo before. And last year, I founded a new center, M&D Data Science Center at Tokyo Medical and Dental University as a director. And also I'm serving as a sub-program director of Cabinet Office Strategic Innovation Program, AI Hospital. Program director is Yusuke Nakamura. He is a very famous oncologist. And my talk is maybe the half of my talk is that, and then I will start it. Just a moment. Cancer genomic medicine enhanced by AI. This is a case study at the Human Genome Center, and I want to show 2 episodes, maybe 1 episode is enough for introduction. Well, the bottleneck of cancer genomic medicine is the following. After sequencing whole genome, cancer genomes, we will face with the millions of somatic mutations. And the problem is their interpretation. Interpretation means cancer biological interpretation and therapeutic translation. Those are bottlenecks in cancer genomic medicine because we face with a huge number of somatic mutations, which are driver gene and mutations, and that is a problem. And this was indicated, this bottleneck was indicated many years ago, and they thought AI and data sharing is a solution for that. And I also thought that. And at the Institute of Medical Science, we made a team consisting of 25 members. They are clinicians and bioinformaticians and people working on LC fields, and also technicians and wet lab technicians and so on. And our center has a supercomputer system. And in order to solve the bottleneck I just mentioned, we introduced IBM Watson for Genomics at that time. And the currently turnaround time, that means the patient comes to the hospital and the patient receives the direction of therapy. That time is a turnaround time. And currently, based on whole genome sequencing, time includes that sequencing time too. is just 2.7 days, 2 days and 16 hours at the Hematology Oncology Department at the University of Tokyo. So this time is very short, and the bottleneck was solved to some extent by Watson and other AI tools. Episode 1. And one patient, possibly AML, acute myeloid leukemia, the pathological investigation showed that there is a fusion gene, FYP1L1, fused with the PDGF receptor alpha. But that patient is very intelligent and investigated various literature, and he asked his attending doctor, is this only genomic aberration? Any more pathogenic mutations? Then let's whole genome sequencing. And we whole genome sequence analyzed, then more than 7,000 SNVs and 108 structural variations discovered. And we put that data into Watson, then only one was suggested. That is the fusion of FYP L1 and FDG FR receptor alpha. So very fortunately, this fusion gene can be a target of drug already available. So the patient and attending doctor both are very confident and relaxed after that. So the AI helped in that way. And the second is a bit complicated. And the Watson didn't work. And efforts by hematologists contributed a lot. And in 2018, December, a male ALL patient, 19 years old, in remission after chemotherapy, visited our hospital because the attending doctor at another hospital told him and his family, relapse without hematopoietic stem cell transplant, then only 10% survival. But after hematopoietic stem cell transplant, 20% patients die due to complication. And the attending doctor said to the patient and the family, I don't know whether transplant is necessary for your leukemia. And asked the patient, transplant, do you choose or not? Well, the patient are very confused, but this clinic attending doctor is very serious. Simply follow the guideline. Guideline shows patient is in remission after chemotherapy. If MRD is negative, then no transplant, meaning that the cancer cell disappeared completely. And MRD positive, then transplant. But MRD is not identified, meaning that we do not know which cells are cancer cells. In that case, transplant may be considered. And action by his family is they visited our research hospital for second opinion, and our institute team first did whole exome sequence analysis together with Watson analysis, but we could not identify mutations which are cause of that patient. And then we did whole genome sequencing and discovered various mutations. And also Watson was employed to do that, but Watson didn't help. But hematologist team found a fusion gene, TAF15 and ZNF384 from the second chromosome and the 17th chromosome. Then our hematologist looked into that region, but response by hematologists at our hospital was, do you know this fusion gene? All hematologists said, I don't know. And then they put two genes, TAF15 and ZNF384, into the PubMed window. Then around 10 literature came up, and that suggests the fusion gene is a cause of leukemia. And our team investigated thoroughly and concluded that this fusion gene can be used as an MRD biomarker for this patient. Then the myeloid before the therapy was sent from former hospital, and we took the myeloid after therapy. Then digital PCR is used to identify that fusion, the cells appear with that fusion gene appear or not. And conclusion is, before there are a lot of such droplet containing that fusion gene, but after that, completely disappeared. The conclusion is that MRD negative. And interestingly, therefore, that patient can avoid high-risk hematopoietic stem cell transplantation. And actually, that patient was the 19th case in the world whose cause is that fusion gene. So this is, and the IBM Watson didn't suggest any, and we claimed to the US IBM, and after 1 month's work, IBM reported to us, and that fusion gene clearly appeared by improving the learning technology and reasoning technology. So unfortunately, Watson for Genomics was a good buddy, but did not handle time course analysis, epigenome data, and so on. And last year, December, IBM ended the service of Watson for Genomics because that company want to focus on more image analysis. But our efforts of 10 years made a chance at Department of Hematology at IMS change, and arrival of oncologists armed with AI, powered with the exoskeleton. That's it. Thank you.
Thank you so much, Professor Miano. Thank you so much for giving us a taste of your work. I forgot to mention that, obviously, as you said previously, you led the Human Genome Center at the Institute of Medical Science at the University of Tokyo, and obviously you took all the groundwork that was being done there to the new M&D Data Center, which was just recently established last year. So I think in the question bit, there will be lots of questions, and I'd be actually very interested to hear more about the center and how you work there, and what kind of people work there, and what kind of people you're looking for in terms of international cooperation and collaboration. Thank you for this taster. We'll move on to Professor Wolfgang Neidl, who's joining us from the lovely Leibniz-Universität in Hanover, which is a wonderful location and should be my hometown. And he leads the so-called L3S Research Center that develops methods and technologies for digital change. And as Katja just mentioned previously, the newly founded Leibniz AI Lab is part of this. And this Leibniz AI Lab is one of only 3 international future labs funded by the Federal Ministry of Education and Research as part of the German AI strategy. So congratulations on that. Professor Neidl, the floor is yours now, and we look forward to your presentation.
Thank you for the nice introduction. Let me just share my screen and put on the slides. Yeah, okay, I'm really happy also for this invitation, this possibility of introducing a little bit of what we are doing. Also in the context of reaching out to everybody interested in collaborations or in coming to Hanover doing PhD, postdoc, guest professorship. So let me just introduce the LCRS Research Center AI in Hanover. We do a lot of different things. I will obviously just focus on a few. The focus and core of what we do is what we call intelligent, reliable, and responsible systems. Right? And on one hand, this is all about AI, a very broad including machine learning, vision, semantics, but also other issues which are important in such a network context, and also adding important aspects which are related to law, sociology, and ethics, right? Which, after all, as you know, are really important in this context. We are active in a lot of different basic research projects, which include several European PhD networks and graduate schools, and in ERC grants. We have several members mainly from Hanover and Braunschweig. Many of us are computer scientists, but as I said, we also have colleagues from law, sociology, and medicine. And we currently have about 100 plus PhD and postdocs in our center working on these topics, and also on topics with strong interdisciplinary collaborations. I will focus today only on medicine. Okay, so this shows a little bit the large variety of AI topics which we are working on. I will not go through this list, just take a quick look. We are continuously extending these topics with new professors, guest professors, and also researchers in various levels of their research. Maybe as the main focus, and this allowed us also to successfully apply for an international future lab financed by the BMBF in the context of artificial intelligence. There's one in Munich, one in Berlin, and one in Hanover, which are financed with about 5 million for the next 3 years. And the main idea here is really to bring together a large and competent set of researchers, both from Hanover and abroad. We have partner labs in I would say almost all continents. I think that's one of our strengths. And we have a large set of PhD and postdocs who work together in this context on, again, you would have guessed it, intelligent, reliable, and responsible AI and data science, and specifically on various use cases connecting to personalized medicine together with our colleagues at the Medical University. And this is because whenever we talk with our colleagues from the Medical University, they tell us about the very interesting but also very heterogeneous and broad data they have available about patients, right? And I think many of you know what kind of data is involved here. It's really very broad, including genome and transcriptome, proteome data, in various forms. It of course includes clinical data, but it also includes data which is more graph oriented in nature. So this is really a great set of data to work with, even though not always quite trivial, right? Because if you have so many data, you have to invest a lot of work in data processing until you are able to kind of finally pull all this data together and advance medical knowledge and medical therapy. In the Leibniz CI lab, we currently do this in the context of 3 medical use cases: leukemia, mental health, and breast cancer. Let me just briefly show these use cases a bit. First use case is pediatric leukemia, which is the most common cancer among children. Germany is a focus hospital in this context. In Germany, overall, there are around 600 children diagnosed annually with leukemia, and it's really very important to find out as soon as possible, right? These are all small children, as soon as possible, what kind of prediction we can do for a particular patients, and then based on that, what kind of therapy is the appropriate one, because you don't want to overtreat persons, right? All these therapies have side effects, but on the other hand, you also cannot miss out some necessary treatment if it is necessary, right? So finding out and which patient group the child belongs into is really very important, and we try to provide this information to the doctors on top of the data they have about these patients, including genomic, epigenomic, and clinical data. There's a second use case which we are involved in, which is psychiatric disorders, which is actually an interesting one in the sense that if you talk about schizophrenia, for example, or other disorders, it sounds like it is a very clear diagnosis, but in reality, it is probably caused by very different reasons. And what we want to find out here is when somebody is diagnosed with schizophrenia or something else, what are really the causes? And again, the idea is to find out and to differentiate between different patients which seem to have similar symptoms, but who really have different illnesses, so that we or the doctors can treat them in an appropriate way. And again, it's very different data which we have available, heterogeneous data, which we have to integrate before we can analyze it and then try to find out what is really happening here. The last use case currently is breast cancer, which is the most common cancer in women. There's a lot of cases both in Germany and worldwide. Here, the Medical University of Hanover is part of the breast cancer network, and what we try to aim at here again is personalized therapy. Cancer is a very individual illness, if you want, and therefore treatment has to be very personalized. And again, we want to improve treatment, make it even more personalized in this context to help the patients we have here in Hanover, but also in the whole network. Now, what comes up in all of these projects, let me get a bit more generic again and jump to the level of challenges in artificial intelligence, is that we do have a lot of data on various aspects, but really this data only provide us with a glimpse and on some aspects, right, of the patient or of the disease. right? And this is kind of a general observation, which is often forgotten in AI. Really, what we're doing in artificial intelligence is not kind of really learning about the world. We're kind of extracting information out of data, and if this data is incomplete, or if this data covers just one particular piece of the reality, we learn something very restricted, right? You see here this elephant, which obviously we all see as an elephant, but if you just touch this elephant from the front, it looks like a big snake, or if you touch him from the back, right? So this old man says, okay, it's a furry little mouse, right? So you have a glimpse on just a piece of reality, which means that your model and your interpretation is very restricted and wrong overall, right? So this is something we always have to be aware of. And this is a problem we find again and again in this medical, but also in other projects. And another problem is, and this is from a paper, a colleague of mine in Berlin who worked on this. Another problem is that even though we have now with deep neural networks the possibility to really do amazing analysis on top of a lot of data, we find that that these kind of let's say powerful mechanisms find correlations in data which are there, but which might not reflect what it should reflect, right? So this is an example where we have two deep networks, right? One is the Fisher net, one is the deep net. Both of them are quite good, as you can see here. This is a situation where they are asked to just simply interpret what is on a picture, which is a rather easy task, has become a very easy task in the last 8 years, right? So 6 years ago it was still a bit more complicated, but you see that both of these networks are very good in detecting horses, right? Horses are much easier to characterize than chairs, right? If you go to a furniture shop, you find a lot of different chairs, but horses kind of look the same everywhere, right? And then, and this is a technique which has been described by this colleague of mine, Müller. What he has done is basically provided a mean of highlighting what the deep neural network looks at, right? And if you look at the picture on the right, you see, okay, it looks kind of at the horse, at the silhouette of the horse, which seems to be quite useful. While the other network, this Fisher net, looks to the left, bottom left, right, where there's no horse, obviously. But if you look closely at the picture, we see that there's this annotation which is called Pferdearchiv.de, right, which is an archive of horse pictures. So the network has kind of realized that many of the pictures in this training set come from this archive. They are nicely annotated. So why should it look for horses which are maybe a bit difficult to recognize, even if I mean, if they have a rider on them, right? The silhouette becomes a little bit more unclear. It would just look at the annotation, kind of read the annotation and say, yeah, I see a horse, right? Which of course works for this training set, but not necessarily then if you come and shoot a picture of a horse, which obviously does not have this annotation, right? So it's getting fooled. And so this is how I would like to end this presentation, right? This is really what is behind what we call intelligent, reliable, and accountable systems, right? I have seen too often that there's this great AI or data scientist, or maybe even more in many cases, it's somebody who is actually not knowledgeable in AI, but just expects miracle from the technology, right? So you have this data, and then you have this miracle, and then you have this solution, right? And if you hear it like that, it's obvious that this is nonsense, but but too often actually this happens, right? You have this tool and you ask for a miracle, right? If you come to a medical colleague, he tells you, okay, let's just use some AI and then it will kind of mysteriously come up with a solution, which is not what we want and also not what we need, right? If you do medical projects, you have to have an explanation. If you build systems, you have to know why the system is performing like it does, or maybe in which case it is performing correctly and in which cases maybe it is not performing as it should, so that you actually realize where are the limits of your system and where you have to get additional data to get the full picture. And we are doing this in a lot of different projects, of which I'm happy to talk about later. But I think that's sufficient for a very short introduction. And looking forward to your questions in the discussion session afterwards. So
Thank you.
Let me unshare this. Yeah.
Okay, thank you very much, Wolfgang. And thank you also for touching on this rather funny case of explainable AI. I remember another example of Russian versus American tanks that that you probably know as well, that were just being differentiated by machine learning just because the weather was pretty bad in Russia and the weather was sunny in the United States. So that was the algorithm at work. So this is very fascinating, and also I would like to touch on the question of ethics afterwards when we discuss. I can see that a couple of questions are already pouring in. Let me keep the suspense for just a few minutes, because our next speaker is Deva Priyakumar, who is a professor of computational chemistry at IIID Hyderabad. And Deva, you are now the scientific head of the iHub Data and INAI at IIIT in Hyderabad. You work on AI for risk stratification and mortality prediction in COVID-19 and drug discovery, amongst many other things. So we look forward to hearing from you, and the floor is yours now.
Thank you, Almut. So, thanks again for the invitation to be here, and it's a pleasure to listen to others and possibly have some possible collaborations later. So today what I will do is maybe take about 7 to 8 minutes and then quickly give a reasonably high level overview of what we do in terms of AI applied to healthcare. Okay, so I come from this institute called IIIT Hyderabad, and we have two new entities. One is called the iHub Data, which is a technology innovation hub on data-driven technologies, and INAI, which is applied AI center. So we work actually on two different areas. One is the healthcare, and the other is smart mobility. Okay, so at the fundamental level, what we do, it kind of overlaps with what the two speakers mentioned about. So basically, we work with domain experts, like for example, doctors or public healthcare workers or automobile, people from automobile industry and startups, and then we collect data and then organize it in such a way that people could possibly use and then develop new technologies in healthcare and in mobility, right? So we have this data, we collect this data and then annotate, curate, and then make it available, and then we develop technologies based on AI and then possibly create solutions. This is like a complete pipeline that is absolutely necessary when we are starting something new, right? So that way, this is a pipeline. So at the mandate center actually is to kind of go all out from the fundamental research all the way up to startup connect and then industry or societal connect in terms of deploying or in terms of translating whatever we do in the lab to the land, right? In some sense. So how do we do? So we have kind of have different programs. The most fundamental one is what is called the Data Foundation. This is a program that is responsible for creating technologies and build platforms for data acquisition and and organizing data, visualizing, making access, and all the other activities around the data itself. And then followed by this is the technology development and applied research, and then which gets translated. So those are the three major other dimensions, like applied research and translation, technology, business incubation, and also we have different schemes or different programs by which we engage with people at multiple levels. It could be an undergraduate student, or it could be a really large company. For example, one of the major partners in this initiative for us is Intel. We spend a lot of time together in terms of formulating projects and then executing them, all the way. So, as I said, we have multiple programs in which we could support students or hire engineers and faculty level personnel, and then of course we have also been conducting different programs by which we could reach out to students and young researchers and engineers who may be who may not possibly have access to some of these things, right? So being an academic institute, this is important for us in terms of the outreach. Okay, so I think this is what Professor Neidl, hinted at, slightly. Basically, the idea is, so far, there have been a lot of research. One of my colleagues the other way said, AI for healthcare. This has existed for a long time. I mean, what is it new that you're going to do, right? So, I think, there is a renewed opportunity or a renewed interest in the application of healthcare, application of AI in healthcare is because of the kind of data that we are able to acquire today, right? For example, a lot of us wear some kind of smart wearable, like it could be a Fitbit device or Apple Watch or any of those things, right? So, these are very simple devices, and then they constantly keep monitoring some of the parameters, right? Or, it could be like, suddenly I have some illness, and then I go get some imaging done. And then possibly, both Professor Miano and Professor Neidl talked about different kinds of omics data that we can collect from, especially the patients, right? So now the question is, how do we combine data of multiple levels, right? Because on one hand, we are just talking about heart rate, right? On the other hand, we are talking about a whole genome sequence, right? How is it possible, or is it possible at all to combine data of different kinds and then be able to make informed or or develop intelligent systems that can make smart decisions? So that's basically that's one of the areas where a lot of work needs to be done, and then that's where we see that there is a lot of potential, right? Okay, so and then just to quickly take through this, if you look at the participation of technology companies in healthcare or pharma industry, right? So if someone asked 10 years ago, you have healthcare, whether it is healthcare system or pharma industry or tech companies like Google, Microsoft, Facebook, there's absolutely not much overlap between the two, right? But when we look at things today, things are changing. You have healthcare or pharma industry on one side, and the completely tech kind of industry on the other. There's nice confluence, and then you see a lot more and more companies. Actually, there's a statistic in terms of the number of startups that are growing in this particular area in just the last 2-3 years. Exponentially growing, right? Okay, so going back to what we do, again, this is an entity which is less than a year old, and we have initiated some work, and we are still working on, initiating more work in collaboration with multiple people, like, as I said, Intel, and then hospitals in Hyderabad, New Delhi, and there are some non-government organizations which we have started working with, and then we have started, talking to people from outside India as well, and so on. But these are the four major areas in which we are starting activities, or we have started activities in. So one of the fundamental things that is relevant in the Indian context is the public health, because we know that not everyone in the country, given that the population is 1.3 to 1.4 billion, right? So not everyone has access to good healthcare, right? So how do we develop technology, whether AI or not, right, that can affect, or that can actually touch people at population scale, right? So that's one of the major interests of our hub. And then we also have done quite a bit of work in cancer and diagnostics, like Parkinson's and cardiovascular conditions and so on. And the other work that we are starting right now is the mental and neuro health. Some work is happening, and the last one is in drug discovery, right? So I'm just going to, I just have a couple more slides. So, I'm just going to take one particular example and then tell what is it that we have been doing in this particular area. This is under public health, right? So when the pandemic hit us, all of us last year, right? So, what we, one of the things that we started, in collaboration with people from DWIH Hyderabad, where I am from, IGIB is an institute in New Delhi, and then Intel company, and then Gandhi hospitals in Hyderabad and Max hospitals in Delhi. So basically what we did was we started collecting data of patients who were COVID-19 positive, and then tried to capture all of theirs. So we started by collecting their basically record of their stay at the hospital. Like literally we had to go through papers and papers over, and then transcribe them, and then convert into a data which is actually usable, right? And then of course you have the radiology images, and then we collected the genome samples, or the samples from a subset of these people. So now this is the case that I've been talking about. So we have, for example, age as one of the parameters. On the other hand, you have the viral genome, right? So how do we use these in this spectrum, and then use to make useful decisions using AI, right? I think one of the students, I just saw his name, who was who played a major role in this project, is also in the audience, Akshit. Okay, so first thing what we did was we just took all the clinical data, like hematological parameters, like the medications that were administered during their stay in the hospital, and different kinds of lab reports, vitals, and so on. And then we developed a patient risk stratification and mortality prediction algorithms, based on which you could assess, a patient at a very early stage, whether this patient is probably at a risk or not. This is important because we know that only a small percentage of the people who are affected by COVID, go into very serious conditions. If we are able to do this prediction early, we could possibly use the available, or optimally use the medical resources, right? Especially in a country like ours. Okay, so that was the next step. Now we could use the radiology data, and then look at disease progression. And then we also looked at the viral genome. And then basically what we did was, we combined all this data and looked at the outcomes, and then tried to identify mutations that are possibly responsible for severity of the disease, right? So, are there some mutations which are associated with severe diseases, right? We did identify certain mutations. Not only that, we went to the structural level, and then we're able to show that this is possibly the reason why this particular mutation is having, is associated with severity, right? So, as I said, we started from a very simple data of just age, and then went all the way up to viral genome. And then since we are able to, use this, do a multimodal analysis, we are able to look at, different aspects of this particular disease. Right, so maybe just last slide. So basically, the other area that I spoke about is drug discovery. When you have a disease and you want to have a drug that can be used for this disease, one thing that we have come to realize in the last few years is like this whole pipeline can be actually nicely supported by data-driven technologies, right? Before, if you take this pipeline, each part someone specific or someone which has specific expertise has to come and contribute, right? But then this whole pipeline, the different tasks that are to be done can be nicely supported by data-driven technologies, which are actually making this particular process much more efficient than what it is traditionally, right? So I will not go into the details, just to quick conclude, in the last 2 years, I would say, we more and more realize that, the combination of the traditional knowledge along with the, the modern machine learning and deep learning methods can be, can come together to make a difference in healthcare overall, right? So with that, I thank you, and then we'll take the questions later. Thank you very much.
Thank you, Deva. That was a fantastic insight into also the breadth of the spectrum that you cover, from the very small to the big and to translation. You also mentioned the role of usher workers in India, which was entirely new to me. And so just to remind everyone that you've got a very, very large network already, but you're seeking to expand it. So I think there are all kinds of opportunities for different people in different professions to contact you and to work with you.
Yep.
So thank you. And our last speaker is Dr. Gerd Höfner from Siemens Healthineers in India. Gerd Höfner is the Managing Director and President of Siemens Healthcare in Bangalore in India. Obviously India, Bangalore, and he's the Senior Vice President, Special CTO Projects of the just mentioned Siemens Healthineers. Gerd, we are very much looking forward to hearing from you and what kind of work Siemens has been doing for quite a long time and it's doing right now, and the kind of visions that you have and that you work on. The floor is yours.
Yeah, thank you. I'll talk a little bit about AI in healthcare, specifically what we do at Siemens Healthineers. And well, if you look at it, intelligent machines powered by AI will be at our core, shaping precision medicine for a better healthcare. And if you look at it today, what we are offering are automated product solutions to minimize unwarranted variations. That is on the left-hand side of the picture. And typically what is on the market are intelligent and automated devices with push-button features, task and procedure-specific integration of sensors, devices, and reduced variability and improved precision for diagnosis and procedures. And what is offered today with automation is also, let's say, workflow optimization and reduction of the operating costs. Tomorrow, we will have intelligent machines which enable precision decision making. So we will have a real-time decision support, and we will also use machine learning, powered image reconstruction and post-processing. There will be bi-directional interaction of hardware and algorithms in design and operations. There will be new and precise, timely supply of data from networks of sensors, and machine learning will also be optimized, and there will be automated procedures and workflows in labs and hospitals. And the future will be connected, intelligence, which expands the healthcare availability. And if we look at how today looks like, well, now it should move to the next slide. Okay, here we go. So even today, digitalization and AI is already a part of our portfolio. Here on this slide, I've 3 examples what we are doing today with artificial intelligence. On the left-hand side, you see the so-called Syngo virtual cockpit, which is a remote scanning assistant improving access and provider productivity. The Syngo virtual cockpit allows a more flexible deployment of experienced personnel across different locations. And it also provides a higher level of standardization in reports, leading to more accurate diagnosis, and of course also improves facility productivity in case of personnel shortages. When we come to the workflow automation, so today we have the AI RED companion platform, and the RED stands for radiology. It's an AI-based software assistant for image reading. And what the AI RED companion offers is automatically highlighting of anomalies and abnormalities of multi-organ areas in medical images, including also incidental findings. So it supports the radiologist in diagnosing specific diseases in medical images. It also provides the possibility to transfer results in a structural reporting. And typically the RED companion is specific to one organ or body part and one modality. So for example, the first application that we have launched is the chest CT computer tomography read. And we have a number of additional companions that are under development and will be launched shortly. And then when you look at the machine intelligence and clinical decision support, we're developing something that is called the AI pathway companions. And the pathway companions, typically, they integrate the relevant data to facilitate diagnostics and therapy decisions along a clinical pathway, specifically again for one disease. And it supports the personalized diagnosis and therapy decisions. So it's from the diagnosis to the therapy, and the decision, then the therapy itself, and the follow-up. That's why it's called Pathway Companion, because it supports the doctor across the pathway in helping him making the right decision. So this is what we are working at the moment, and what is, let's say, reality in our portfolio. And then if you, here we go. Now, if we take an outlook, how it will look like in the future. So AI will be the lever to move us from image analysis, disease pathways, to what we call a digital twin. And for that, we are using a special system. So we have even today, I mean, if you look at it, in our offerings, more than 50 AI enriched offerings. But we have a team in the US, in the Princeton areas, that works regularly on improving the systems and coming closer and closer to the digital twin. And for that, they are using more than 1 billion curated images. They have a supercomputer called Sherlock with 24 petaflops, and they are doing more than 600 AI experiments per day. Let me talk a little bit more about the topic of the digital twin, what it means. If you look at it, the two fundamental questions in healthcare are usually, number one, how am I? So how am I doing in terms of how is my status of health? And this is what the digital twin, what we will describe in the digital twin. And in case you are not healthy or you're sick, the question then is, what is my path to health? And this is what the pathway companions will describe. And if we look at this in the future, you can imagine, for example, you have on your mobile phone, what you see on the left-hand side, a digital twin of yourself with all informations, the electronic health record, all images, all data from laboratory, genetics, but all vital signs which you can capture from any kind of equipment at home. And this will give you the answer to the question, how am I? And maybe you can also simulate how things will develop in the future if you continue with your current behavior, and maybe we can even forecast in sense of what will happen if you might fall sick in a few years or so on, or what you have to change to ensure that you are still healthy, which also means that AI will support with the digital twin from, let's say, from healthcare, a transition to well-being to ensure that you are continuously in a healthy state. But in case you are, let's say, sick, then question is, what is the path back to the health? And as mentioned before, the pathway companion there will give you a idea. There will be a preview, let's say, with different treatments you can simulate. If you have, let's say, treatment A, it will take 64 days and you have an 89% of likelihood that it will work. Or you have a treatment B, which is faster, 23 days, but only 55% of likelihood that it will help, and so on and so forth. So this is, let's say, the way how we look at the future of healthcare driven by AI, digital twins plus pathway companions. My last slide is a little bit also about the future of healthcare beyond the digital twin. Just to give you an idea what we at Siemens Healthineers do in business transformation topics, I mentioned the digital twin, but we also work on connected health and automation and pathways. And for that, the technologies we are using are AI and novel computing. We also work on IoT, edge devices, and connectivities, where we develop a standardized Internet of Medical Things platform, machine-to-machine interactions, and decentralized processing and cybersecurity. In terms of medical technologies, we work on new and scalable sensor solutions for biomedical models, for example, photon counting detectors, for computed tomography or miniaturized lab technology. And of course, we also look at the whole topic of automation and clinical robots, where we have intelligent systems, autonomous devices, and clinical imaging robotics. And so we work in the area of cyber physical systems, autonomous system technology, mechatronics, kinematic subsystems, and this, of course, all supported by AI, data mining, and the whole topic of intelligent data. And yeah, that's it. Thanks a lot.
Thank you very much, Gerd. This was really fascinating, and I think everyone will remember the digital twin amongst many, many other things. And let me take the digital twin sort of as a buzzword to start with the questions. One of the questions in the Q&A chat is, do you see a risk of sinking competence of doctors due to the application of AI, and what to do about it? So speaking of competence, my next question would be, let me just pose this quickly, what kind of competences do you see are needed in the people who apply to you to work with you? And this question actually goes to all the other panelists as well. Let me just quote Professor Miano. I saw, I heard that you said very few people, and that was a while ago, combine the skills needed for this kind of work, i.e. a biomedical background and data science using AI. So just a question maybe for all of you, is this still the case, or are there enough young trained people, or what kind of people, co-workers do you look for? Who should contact you? Who should introduce themselves to you? Yeah, do you want to go ahead maybe with a competence question about the doctors?
Well, from my point of view, I wouldn't necessarily see the problem, because usually when we look at our teams, we have interdisciplinary teams. Yeah, so you not necessarily need to have a person who knows everything. We have the people who are typical computer scientists or software engineers, or people with a background or computer science specialized on AI. And we also have a number of medical doctors or radiologists, whatever the kind of topic we work on, in our labs, and they work closely together. So from my point of view, it has to be interdisciplinary teams. And what we are looking for are primarily people with a background in artificial intelligence, data science, and computer science and software engineering. And as a company, I mean, Siemens Healthineers, we have a history of more than 120 years in healthcare. We also have the domain competence. So this is something where we will give also, let's say, the respective competences that are required for the colleagues who join our teams. And like I said, we also team up with interdisciplinary teams where we have doctors and colleagues with an AI background combined. I wouldn't necessarily see this as a problem.
Okay, and do you think that AI and sort of human competence can complement, or is that just too optimistic a view?
I would say it's complementing in any case. I don't think that AI will replace in the long run, especially in healthcare, the medical doctor. Yeah? So the way we look at it, it is something where we help the medical doctor to do their jobs better and to make their lives easier. If you look at it, for example, today, a radiologist, I mean, at how many different pictures he has to look at, and the time, the pressure is getting higher and higher, and he has less and less time to look at the images. So what we develop, we call it a decision support system, and it's there to support the doctor, but not to replace him.
Okay, that's that's a relief. Thank you. Professor Miano, could I get your gist on this question?
Well, as Gab mentioned, the interdisciplinary work is very important. And when I was at the University of Tokyo Human Genome Center in collaboration with research hospital clinicians, it's a really interdisciplinary team. Yeah. And as you know, the hospital departments are divided into pieces and no communications between them. So for example, cancers are divided into organs. So the blood cancer clinicians are not familiar with solid tumor matters. So but from our experience, the people who gathered, blood hematology people and solid tumor people work together, then they will find new insight into cancer and also new therapy. That is, and about the fostering people, at my new center, M&D Data Science Center, and we are planning to foster people with MD background with artificial intelligence ability. And I just stayed for 1 year and a half at the current institute, university. We saw several students who are very much interested in artificial intelligence, but they want to keep their background as MD. Yeah. So I think maybe very near future, medical doctor with artificial intelligence ability will appear, and they play a very important role in the artificial intelligence applications into medical practices.
Yeah, thank you. Wolfgang Neidl, would you share your thoughts on this with us?
I think on this particular question, quite a lot of things have already been said, right? But in general, it's the role of AI to give more tools, right, and to make interfaces more more intelligent, right? Because if you have so many data, it's impossible for a human to use all of them together, right? So human decision making is very much based on experience, and this is what humans are good at. But if you lack experience in a particular aspect, right, or if you have additional data which would be available, this is not something which humans can very easily use, right? And AI techniques can actually help to use these additional data, or also to complement what the doctor knows in areas where he has not yet gotten any experience, right? So this is, I think, a very complementary and very important aspect.
Yeah, makes sense. Thank you. Deva, I was wondering if you could give us your gist on one of the questions that popped up in the chat. What are your views on challenges for democratizing the healthcare data to research and academia? Is that something that you think about? Or maybe you can also say something about the whole issue of data sovereignty, which we haven't touched on so far.
So yeah, in general, when we talk about data, that comes up with a lot of concerns, right? People already mentioned about the fairness, accountability, and then the privacy and all other aspects. Especially when it comes to healthcare data, that's of course it's going to be much more sensitive, right? So in that sense, see, that's possibly one of the reasons that why we don't really have a large amount of data in healthcare space that the researchers could possibly use, right? So for example, in the center that we started from the get-go, we said we will, start when we do the data collection, we will make sure we follow the best practices, and then make this data available to who are students or researchers in the universities, institutes, startups, for example. We will make this available. There could be some terms, for example, you may have to sign some NDA or do some licensing on all that, but all this data, or most of the data, will be available. For example, the COVID-19 data that I spoke about, that data, anybody could write to us and then get it after signing certain terms based on the ethical committee decisions that has been made in the hospitals and in the institutes that have been part of. So yeah, absolutely, yeah.
Okay, thank you. So let's see what else we have in the questions. Bit of a different question maybe is, could you please provide AI models creating for reducing fraud detection for healthcare claims, for healthcare payers, and reduce administrative cost? Anybody want to say something about this kind of application? Maybe not. So we go on to
I'll go.
Okay, you'll go. Thank you.
All right. So, see, one of the areas that that's very active, and then a lot of companies are interested in, is like when you get insurance claims, right? So there are certain patterns that that can help us identify fraud claims, for example, right? So identifying this is not very easy, and there's a lot of research that is going on in terms of detecting these these fraud claims and the insurers. So there's a lot of work available. We don't personally work on this, but then work exists in this area. I don't think there is a model that anybody can use it right now, but there's a lot of research going on in this space.
Okay, thanks. Then another one, from my experience with neural networks, I cannot see how we qualify the medical doctor who's doing the diagnosis at the end for using AI properly in the long run. Or will doing diagnosis in the future mean that this has to be done by an interdisciplinary team together with AI and AI experts? To do diagnosis in teams of this kind could be of high quality, but it's very expensive too. Who wants to jump into this? Satoru, you're nodding, so I'll call on you.
Well, the problem is how to cover the AI device and the tools in real medical practice. And as long as the software and some kind of software applications are approved as medical device, then in Japan, health insurance system can cover the cost, and hospitals can get money from by using those AI application softwares and so on. However, AI, for example, natural language processing tools, those kind of software depends on the data. Such data changes from time to time, and knowledge also changes from time to time. For example, some mutations are not recognized as pathogenic. However, after 5 years later, then, well, this gene, this mutation is pathogenic in another kind of cancer. This kind of thing happens very often. Therefore, the AI applications based on knowledge is changing time to time, and how to approve such medical oriented applications as medical device, that is a big problem. Yeah. And in Japan, the diagnosis is not done by medical device, but by clinicians. The final responsibility is to clinicians. And such medical device and the AI application tools simply assist the clinicians to make more precise or high precision diagnosis.
Thank you.
Yeah,
This
it's
might,
a very
yes,
important problem issue. Yes.
very important. And maybe also a case for learning from each other internationally, which kind of brings me, sorry, Gerd, you were going to say something.
Yeah, I would just like to add what Professor said. I mean, the question was from how we qualify the medical doctor who is doing the diagnosis for using AI properly in the long run. Yeah, I mean, this is not required because the medical doctor, he uses a software, a tool, and for that he's not necessarily, he doesn't have to be an expert for AI. And this is also what the professor said. The software will be classified as a medical device. And if you have, let's say, a medical imaging, let's say a scan, CT scan or MRI scan, then the software, the AI will point out where there are areas where there might be something wrong. And in this way, it's supporting the medical doctor. But the doctor doesn't necessarily be an expert for AI. So in this sense, this problem doesn't occur at all.
Okay, thank you for clarifying. Satoru?
Yeah. Yeah. Well, as long as the images and some signals from devices are input to the AI software, it's okay.
Exactly.
It's okay
Yeah.
as a medical device. But input are, in a sense, fragile knowledge and changes from time to time. Then we do not know how to qualify the goodness of AI applications in medical field. And we do not have any benchmark in that case. So, well, you know, Google API from phonetic to letter translation, that works very well. But how to qualify that? For example, in the field of, in the practice of medical field, in the hospital, and aside the bedside, in Japan, the languages, Japanese languages used there are very different from the languages spoken in the street. So the translation, automatic translation to phonetic to letters are also very difficult now. And qualification is a big problem.
Okay.
Yeah, sorry.
But sorry,
okay.
thank you so much. We could probably go on talking about this for a very long time, but we need to draw to a close. Maybe one final hint or question. I just wanted to point out once more that all of our panelists are very open to your applications and contacts. So if you've gotten a good taste and kind of a gist of who they are and who they work and what they work with and the kind of fields that that's their area of expertise and what they're looking for, I think I may encourage you to get in touch with all of them. Wolfgang Neidl, just you told me in the beginning that you have a fantastic network of internships and a huge international network. So maybe you can start with final words of wisdom, and then we go to Deva and Professor Miano, and then Gert Höfner, maybe for one or two final sentences just to draw the session to a close.
Thank you, Almut. Yeah, it's really a very important. So in general, obviously, as you know, research is international, right? And this is why we are strong together, and especially in the context of Leibniz AI International Future Lab, I really welcome any applications or any questions for collaboration on all levels, from PhD, postdoc to the professorship level. So we have guest professorships available. We have PhD and postdoc positions. We do have a very strong partner already in IIT Kharagpur, right? I would be very happy if we can expand this because we have already quite a good group of excellent PhD and researchers from India, right? Which are looking forward to new colleagues joining us. So if you're interested, please just contact us, and we are very much looking forward to further deepening our collaboration, which we value a lot with Indian universities and Indian students.
Thank you, Wolfgang. Deva, you're next.
Yeah, thank you. So, yeah, as I mentioned in one of my slides, we do have opportunities for people at multiple levels. If someone is saying that they just want to learn something, they could just visit us for a short term or 1 year or 6 months, whatever that is, and then do some courses here, or they can work with some of the professors here or engineers here. And then, we do have other kinds of fellowships like the PhD fellowships, postdoc fellowships, and then young faculty program, and then visiting professorships. And then, of course, we are actively hiring engineers who have worked in the areas of data architecture, machine learning, and deploying, and also people from the domain like healthcare and so on. So this is with respect to individuals, but then in terms of collaboration, we are very, very open. And of course, we do have a reasonably large network right now, but we are, more is merrier. So we would like to work with, as many people as possible there. So, if people do not know, IIIT Hyderabad is one of their strongest AI group in the country. If you take in terms of the papers or the in terms of publishing, or in terms of the number of people working in the areas of intelligent systems, this is possibly the largest institute in the country. So yeah, so please welcome. Yeah.
Thank you. Satoru, your final words of wisdom.
Well, I think in addition to the advancement of AI technologies, we need networking over the countries, because the healthcare systems are very different and cultures are very different. And I think AI can contribute to healthcare area only if we understand the culture and healthcare and the social systems and so on. And that combination could be realized by international networking. Especially young students are very much welcome to that network.
That's very encouraging to hear. Thank you. Thank you very much. And Gerd Höfner, you've got the final minute or two for your final statement.
Yeah, well, what we are looking for, I mean, I can only encourage colleagues who are interested to work in healthcare and have a background in digitalization topics like AI, data science, and all the other topics, IoT, and so on and so forth, to apply at our center in Bangalore. Why? I mean, there are a number of good reasons. Number one, according to Great Place to Work, we are the best place to work for in India in the healthcare industry. That has been announced last month only in June. And the second thing is that was, I think, all over the newspapers last October. We announced that we are building a new campus in Bangalore, which is a major investment, biggest investment of Siemens Healthineers in the whole history in India. And so we are building a campus, and this campus also will be, let's say, an innovation hub for Siemens Healthineers, 1 out of 4 worldwide innovation hubs. And we are also planning to set up a special center for digitalization as a hub for Siemens Healthineers. And we are recruiting up to 2,000 people over the next years, specifically in those areas. And I mean, from my point of view, if you're looking for a job where you also have a high purpose, healthcare industry is the best area, and Siemens Healthineers is the best place to work in India.
Thank you very much. And thank you very much to the esteemed panelists. We are fantastically punctual. And I'd like to close this session now and thank all the viewers and listeners for spending their time with us. And it was, for me, very inspiring. I learned a lot, and I hope to be in touch with everyone. And don't forget, dear listeners and viewers, to get in touch if you're interested in working with any one of the 4 panelists. And more than ever, stay healthy. All the best.
Yeah.
Thank you. Bye-bye.
Bye-bye.
Bye.
Bye-bye.